Okay, grade 12. This is actually the this lesson is advanced, is above the BC curriculum. You don't need to if you don't want to, but if you want to gain a better understanding and deeper understanding of physics, and you have some extra time, I suggest you to actually learn this. So this is about multiplying vectors. So it's about vector multiplication. And in order to do that, I want to tell you, vectors are not numbers. They are different than scalar quantities. Vector quantities are different than scalar quantities. As you saw before, their addition is different than adding numbers to each other, right? And the result of adding two vectors is actually another vector. Now, let's look at multiplication of vectors. We have two kind of multiplication, two kinds. One of them is called dot product. So the dot product is when I have vector A times vector B, and the answer is a scalar quantity. The answer is not a vector, is a scalar quantity. And this deals, of course, these are vectors, right? This is A and this is B. If you multiply them together, there is an angle between them. This angle, if you want to call it theta, the cosine of this angle is what you use for this multiplication. So this would be the magnitude of A times magnitude of B cosine theta. This would be actually A times B. So vector A times vector B, the answer would be like this. You remember your unit circle, right? As you can see, this is cosine, right? As you remember, and this is sine. The bigger your angle gets, now if this is your angle, this would be the cosine of that angle. So the bigger the angle gets, the smaller the cosine gets. So the bigger the angle between these two gets, the smaller the result of the multiplication would be, right? So as theta gets bigger, the C decreases. It gets smaller. The result will get smaller. So now let's talk about the other kind of multiplication, which is called cross product. Let's use another color for this one. Cross product. Also called vector product, because the result of this is actually a vector. And of course you write it like this. The name shows it's cross product. This is dot product, this is cross product. The result is actually a vector. And the direction that this vector shows is very interesting. The direction of this vector is out of the surface of the A and B. I'll show you how it is. Let's say this is A. Let's say this is B. The C, actually, let's say this is A, and this is B. From A, go to B, this is C. This is C. So, I can show it in diagrams also. Let's say if, for example, if this is A and this is B, this is A and this is B, your four fingers of your right hand, right hand, remember right hand, the forefinger goes from A to B, this would be the C. So the C would be coming out of the picture like this. If you want to show it in a surface and say, okay, this is my A, and I'm gonna show it here. This is my A and this is my B. From A to B, of course, the C would be perpendicular to the surface. This would be the C. Yeah, and in this case, we have some different situation. The answer would be magnitude of A times magnitude of B sine of theta in this case. In this case, here was cosine, and here is sine of theta. And of course, the whole thing is a vector, and this is a vector here. Look at a very interesting point in here. You remember your unit circle. This is the sine. Of course, the bigger your angle gets, like if this is theta, this is your sine of theta. The bigger it gets, the bigger the result gets. So the bigger the angle gets, if these are your vectors, the bigger the angle gets, the bigger the result of C would be. Opposite of this one. Yeah. Now, I want to look at another difference between these two multiplications. As you can see in here, A times B let's see the relationship of A times B. Let's have a quick look at our unit circle again. This is the cosine that we are dealing with. We are dealing with cosine, and this is theta. This is negative theta. Look at this. This is negative theta, which is equal to theta, just different direction. It goes this way. The cosine of theta and negative theta are equal. You can see in here that the cosine of theta equals the cosine of minus theta. Yeah, you can see that. So, therefore, the A times B equals B times A. You can you can actually change the order in this kind of multiplication, because AB cosine, in this here you have AB cosine theta, and in here you have BA, which is the same as AB cosine negative theta. And of course, these are numbers, these are just magnitudes. You can change the order, but for this part also, these are equal, so you can change the order. So this is obviously equal. Now look at this other one. In this case, such a thing doesn't exist, because A times B does not equal B times A. They don't equal. Why? Of course, in here you have AB sine theta. In here you have BA sine minus theta, or negative theta. And these two are not equal. This part is equal because these are numbers and you can always change the order of multiplication. However, this part is not equal because, remember your unit circle again, when you are dealing with the sine, if this is theta and this is negative theta, you can see that the signs are different. They are equal in magnitude, but they're different in the sign. So this is whatever it is. Let's say this is let's say this is 2/3. This is 2/3 negative. So these are 2/3 actually. So these are two negative. They're different. They are not the same. So they're not equal. Maximum, you can say that. Okay, you can say A times B equals negative of B times A. That you can say, yeah, but they are not equal. So this is also something important about this vector multiplication. This is very much used in physics. I give you the examples in the next video.